Yes, hi everyone. Good evening. Am I audible to all of you? Can you please confirm in the chat? Yeah, hi Atul. Hi everyone. Yes, hi everyone. Okay, so guys, I think we can start the session and welcome to day 10 of our computer vision for developer series. And I think guys, so far your learning is going good and you are able to understand all the topics, okay, whatever we have completed so far. And if you're joining for the first time guys, let me tell you. So this is the playlist guys we have started called computer vision for developers. Okay, so here we have completed till day 9. So first of all, try to complete all of the session, okay, till day 9, then you can start from here. Okay, and if you feel like okay you already know these are the topic and you want to start from this video, you can also continue from here. Got it? And guys, one thing I need from your side guys, please try to support my channel. So if you are first time here, okay, if you haven't subscribed yet, so please try to subscribe and also try to give the like in my video, and you can also share with your friends and family. Okay, and if you need anything else from my side, let me know. Definitely I'll try to bring that content here. So let's try to hit 50k subscriber guys as soon as possible to my channel. Yeah, new series of AI agents, definitely. Okay, we'll try to also bring that content here. Yeah, no coder. Walaikum assalam. Thank you. So guys, we can start our today's agenda. Like we'll be talking about the transfer learning and pre-trained models. Okay, so far we have seen like how we can create our CNN architecture. That means we have learned everything from scratch. And I told you, if you are using like CNN from scratch, okay, that means the custom architecture. So there you have to train, okay, you have to train that architecture from scratch, okay, and you have to do different experiment with the architecture. And it's like very hard task because to figure out the best model, it will take lots of time. So that's why we will be using something called pre-trained model. Okay, pre-trained model means this model is already trained with some data. Okay, and this model knows actually some of the let's say objects, some of the let's say category. So what I can do, I can use the pre-trained model and I can do the inference on top of that. Even I can also use this pre-trained model to fine tune on top of my custom data. Okay, it is also possible. So first of all, I will talk about this pre-trained model. What is pre-trained model exactly? How this idea came, okay, why we need this pre-trained model. So each and everything we'll try to understand. Then I will also show you the practical demo of the pre-trained model. Okay, how we can utilize the pre-trained model for different classification tasks. Then I will start with the transfer learning. So there I will show you how we can take existing pre-trained model and on top of that how we can train our own data set. Okay, this thing we'll try to cover. So transformer architecture code from scratch. So this is see, transformer is the NLP architecture. So in this series I'm not going to show the transformer architecture. Okay, maybe if I start any kinds of NLP series, there I'll be talking about the transformer architecture. Sir, can you please create an end-to-end tracking? Definitely we'll try to see that. Inception BD, hi sir, how are you? I'm fine. What about you? Yeah, so guys, now let's me start. So here I'll open up my Blackboard and let me write down the agenda. See, today the agenda is, so here we'll try to cover pre-trained model. Pre-trained model. Okay, pre-trained model in CNN. Then next thing I'll be talking about the transfer learning. learning. Okay, transfer learning in CNN. Or I can write computer vision. Hmm. Yeah, vision transformer I'll be talking about. Okay. Hmm. So first of all, let's try to understand why. Okay, why we have to. So here, let me write why we use pre-trained model. Pre-trained model. Hmm. So I think you know that, guys. The first, let's say, the first component you can understand. See, deep learning is all about data hungry. Okay, data hungry. Okay, I think you already know that. Deep learning model usually data hungry. So here you have to feed massive amount of data, okay, to get a good model. And here we are working in the field of computer vision. That means we are working with image data. Okay, image or video data. And video is at the end, it's an image only, right? Video data. Okay. And not only image and video data, here this data should be labeled. Okay, this data should be, guys, labeled. So what is labeled? I think you saw I showed you one classification, right? So there we collected tomatoes, okay, tomatoes and this apple image, and this was annotated. That means there was a folder structure inside tomato folder. Okay, that means here I can write inside tomato folder I have all of the tomato image. Then inside apple folder, okay, I have all of my apple image. That's how, if you are collecting for other category, you have to create the folder. Inside that you have to keep all of the image. Okay, fine. Now let's say you have collected, let's say randomly you have collected 10,000 images, 10,000 images from Google. You have downloaded from Google. Okay, let's say you have collected for cat, you have collected for dog, you have collected for horse. Okay, then you have collected for, let's say, frog. So these are the images you have collected, total 10,000 images. Now this is random image, guys, right? Inside one directory, let's say inside a image folder, these are the images present. Okay, but what I have to do, guys, if I want to use this data, okay, if I want to build an image classifier, I have to first of all label this image. Okay, how to label? First of all, I'll create a cat folder. Inside cat folder, I will keep all of the cat image. Okay, then I'll create a dog folder. Inside dog folder, I will keep all of the image. Inside horse folder, okay, I'll keep all of the horse image. Inside frog folder, I'll keep all of my frog image. Okay, that's how you have to label. You have to label for all the image. And if you see here, you are having 10,000 images. Sometimes you will be collecting 1 lakh images. That time it would be very much hard task for you to label that particular image. So this is the labeling for the image classification. Now going forward, whenever we'll be learning about object detection, image segmentation, their data labeling is very much hard task, because there you have to create the bounding box, you have to create the polygon box. Okay, so it's like very hard task, right? You have to individually annotate those are the images, okay, one by one, and it will take lots of time. Sometimes, okay, what you have to do, you have to hire some people, okay, to do the annotation. So let's say there is a company, if they're building this kinds of model, okay, if they're collecting this kinds of data, they need some people, they will be doing the data annotation only, and they have to provide the salary to that particular people. Okay, so again, it's a time taking task. Again, it's a costly task. You need a budget, okay, for that. Got it? Yes or no, guys? Hmm. Then again, what you will do, let's say you have somehow let's say categorized the image. That means you have labeled it. Now you will be training a model. Okay, you will be use a model. Let's say here we are using a custom model, custom CNN model, and we know that to train the custom CNN model, I have to train from scratch, because this model is completely new model. Okay, and I have to train it from scratch. And to train this model, I need good GPU. Okay, then I need data. That means lots of data. Here I can write massive, or I can just write lots of data. And I also need time. Okay, so these are the thing I need to train this model. And again, if you are using a custom architecture, you have to select the best model. Okay, you have to select the best model, which one will work better with respect to the data. That means you have to train it, you have to see the results, again you have to update the model, again you have to train. That means here lots of time is there, lots of cost is there, because if you want to take a GPU, at the end you have to pay for that. It's not a free. Okay, so you need the cost, you need the time, again you need lots of data. Okay, so that's why guys, people started using pre-trained model. Okay, now let's try to understand how this pre-trained model came. Okay, how this pre-trained model came and what was the, let's say, idea behind it. Got it? So see, there was a data set called ImageNet. Okay, ImageNet data. ImageNet dataset. So this was the dataset created back in 2006. 2006. They call it as visual database of image. Okay, visual database of image. Okay. Now there was a person, his name was Fei Li. Okay, so he was created this particular data set. Okay, before. Why? Because that time he observed people are more focusing on the model development. Okay, model development and algorithm development. Okay, algorithm development. That means people are experimenting with different model and different algorithm. Okay, that time he realized that, okay, so if anyone is creating the model and if he wants to test that particular model, so definitely he needs the data, yes or no, right? He needs the data. So that's why he thought, if I can create a data set, okay, if I can create a data set and it will have all kinds of category with a massive amount of database, so this particular data set will help to this kinds of model to evaluate whether this model is good or not. Okay, in the field of computer vision. So that time actually what he did, he collected around 1.4 million. Okay, 1.4 million images data. Okay, images data. Got it? With 20,000 different category. 20,000 different category. Okay, so inside the category, let's say he collected for the dog images, he collected for the cat images, he collected for the horse images, person images, car images. Okay, that's how 20,000 category, okay, he collected from the internet. Okay, now again, he didn't only collect it. Okay, what he did, he also did the labeling operation. Labeling. Okay, labeling means, let's say, cat image is present in the cat folder, dog image is present in the dog folder, horse image is present in the horse folder. That's how he labeled that particular image. Okay, so it was like a very hard task for him, because he collected the entire data set. Again, he performed the labeling operations. Not only these kinds of labeling, he also did for the bounding box labeling. Let's say there is an image. Okay, there is an image, and inside this image, let's say there is a person. Let's say there is a person. Okay, so he also created something called bounding box. That means where this person is located. So this is called object localization. Okay, and we can also use it for the object detection. Okay, so he also did this kinds of annotation, this kinds of labeling. Got it? Now how he collected the data? See, he performed one survey. Okay, what kinds of survey? So see, he did actually one crowdsourcing operation. Crowdsourcing means, let's say he was using a service called Amazon Mechanical. Okay, Mechanical Turk. Okay, Turk. So what he did actually, he let's say launched different captcha. So I think you know guys what is captcha, right? Let's say you are working in a website. Let's say this is your website, and the website name is, let's say anything you can write, x.com or anything you can write. So let's say you are inside this particular website and suddenly, suddenly there is a window will pop up to you. And let's say in this particular window, there is a person image. Okay. And here it will have different option. Let's say this is the first option, this is the second option, this is the third option, like that. Now it will ask you, what is the object is present inside this image. Now what you can do, guys, you can select the right option. Let's say this is the person, so I'll select the person that time. Let's say this is the correct answer. So that's how it will actually open for all the users who they are using the internet. Okay, just try to remember, guys, inside in the world, okay, how many people are there, they're using the internet. So if he can show, okay, one particular window, one particular captcha window to 10 million people, or let's say 1 million people, so he can able to capture, okay, 1 million data, okay, with an annotation. Are you getting my point? Yes or no? Tell me, guys. Got it? So how he collected the data? This is called actually crowdsourcing. Okay, so sometimes, see, if you are using any kinds of website now, so you will be getting these kinds of captcha. That means they are collecting some amount of data. All right, so that's how, guys, he did the crowdsourcing and he collected these kinds of data, okay, from the internet. So he utilizes the entire, okay, he utilizes the entire, let's say, users, those who are using, okay, internet. So to them, he launched these kinds of captcha with the help of this Amazon mechanical Turk, okay, and he was able to collect these kinds of images with the label as well. Hi sir, please upload detailed video on object detection and tracking, RF, DTR and DeepSort custom data. Yeah, we'll try to see that. Yeah, so that's how, guys, he built around 1.5, okay, sorry, 1.4 million, okay, 1.4 million image with label, okay, with label. And this labeling was like that. Let's say you are having two different cat, or let's say you are having two different dog. One is black dog, one is golden retriever. See, he also categorized in that way. Let's say this is the black dog, this is the golden retriever dog. So first of all, this is a dog class. Okay, inside dog class, what kinds of dog class it is, whether it's a black dog, whether it's a golden retriever dog, whether it's a bulldog. Okay, so this kinds of let's say labeling he has also done in that particular data. How? Because of this particular captcha technique. Okay, yeah, so he he actually didn't do it manually, so he utilized the entire crowd to do the annotation. Got it? Yeah. And this dataset, guys, this is the benchmark dataset. So the ImageNet dataset he have built, ImageNet dataset. So this is called actually benchmark dataset. Why benchmark dataset? Because there is a competition called ImageNet competition or ImageNet challenge. Okay, was there at that time. So in the ImageNet challenge, guys, what people used to do, okay, so people used to create different architecture. Okay, so that time actually deep learning was not available. That time people used to work with the machine learning model, ML model. Okay, ML model. So they used to create different ML model and they trained on top of the ImageNet data. Okay, ImageNet data. And the good thing is there, in the ImageNet challenge, actually, he didn't utilize the entire 1.4 million data, okay, or 20,000, okay, 20,000 category. Instead of that, what he did, guys, he only used 1 million data, okay, 1 million data. That means this is the subset of the entire data, 1 million data with 1,000 category. 1,000 category only. Okay, So this was the data, guys, they are using in the ImageNet challenge. That means people are creating different machine learning architecture, machine learning model, and they were training on top of this particular these kinds of data. That means your ImageNet data, and they were trying to reduce the loss of the model, okay, loss of the model, and try to increase the accuracy of the model. That means if you see in 2010, okay, 2010, people are able to achieve so see, there was a error rate. That means error rate is 100%, okay, let's say 100%. If error rate is 100%, they are able to reduce till 28%, okay, 28%. That means let's say if the complete error rate is 100%, okay, so after creating the architecture and after using ImageNet data, the error rate was 28% in 2010, okay, with the machine learning model. Then in 2011 also, if you see, people are using different architecture, then they were able to achieve 25%, let's say, error rate, okay. Then in 2012, okay, in 2012, whenever CNN came in the market, let's say there was a researcher called Jan LeCun, okay, Jan LeCun, I think you remember, na, Jan LeCun, okay. So he proposed the architecture, okay, and there was another architecture called AlexNet. AlexNet architecture, author or researcher, AlexNet, who has published? Jeffrey Hinton, yeah. So Jeffrey Hinton, he also proposed this AlexNet architecture in 2000, okay, maybe in 2012. This was the first CNN architecture, and the error rate was 16%, guys, that time, 16% error rate. Okay, so that's how whenever he proposed these kinds of let's say architecture, that means CNN architecture, so people are more focused on the CNN architecture that time. And after, okay, after this 2012, that means 2013, 2014, okay, 2015, people started creating different architecture. Like that means you have AlexNet, you have VG16, you have ResNet, okay, you have Inception net. So that's how there are different architecture came in the market, and those architecture were able to reduce the error rate, okay, with a very good amount. Got it, guys? Hmm. Day 10 of transfer learning, but Ilbro still hasn't transferred a single line of code. No PyTorch, no collab, just him screaming theory like a his TED talk. Okay, ASM Rafiu. Okay, I don't know. I mean, whether you are joining for the first time or not. Okay, to my live. Okay, so the line you have written, this is not correct. If you start from day 1, okay, and if you complete till day 9, then I think you will be able to get your answer. Okay, whether I have written a single line code of or not. Okay, whether it is a TED talk or not. So please don't put these kinds of messages in the chat, okay, because the things you are telling, this is not the correct thing. Okay, yeah. So here everyone is okay, coming for learning something. So don't push these kinds of unnecessary messages, okay. This is my request to you. If you're not liking my content, feel free to leave the session. Yeah, so there are so many YouTube channel, you can maybe go through the code, okay, the code you are looking for if you're not getting from my content. Okay, maybe you know a lot, okay, that's why it's easy to you, but here we don't know anything, we are exploring the topic. Fine, so guys, I think you got it. Okay, so how this idea came, how this ImageNet came, okay, why this dataset is came, and how this ImageNet challenge was started, and how people have started using this ImageNet data, because this was the benchmark data. And if you are publishing any kinds of model, I told you now, if you're publishing any kinds of model, any kinds of CNN architecture, you have to train that architecture with the help of ImageNet data. And if you can reduce the error rate, if you can achieve the good accuracy, that time you will be able to publish your own paper. And that time you can claim, okay, so this architecture you have developed, and this architecture can beat any other architecture as well. Okay. Yeah, so that's why we call it as a benchmark data. Okay, ImageNet data is a benchmark data. And we always use the subset of data. We don't use the entire 1.4 million data with 20,000 level. Okay, 20,000 level we don't use. We only use 1 million data set. Okay, and 1,000 category. Okay, so now next thing what I will do, guys, now see, there were some famous architecture as well came in the market, like in 2000 I can write some famous architecture. Famous architectures. Okay, so in 2010 you will see that there was an architect. So if I start from like beginning, let's say in 2010. So here I told you, in 2010 people are using machine learning model, ML model, and that time the error rate was 28%. Then in 2011 again people are using ML model. Okay, and that time error rate was 25%. And in 2012, okay, people started using CNN. So let's say the architecture purpose called AlexNet. Okay, so this architecture got 16.4% error rate. Okay, then if you see in 2013 there is an architecture purpose called GFNet. Okay, GFNet. So this was another architecture. So this architecture got 11.7% error rate. Then in 2014 there was a architecture called VGZ. Okay, VGZ. So this architecture got 7.3. Okay, 7.3% error rate. And this is like very famous architecture, guys, nowadays. Famous, everyone has heard of this VGZ. VGZ has like variant VGZ 16 and VGZ 19. Okay, then in 2015 there was an architecture called Google Net. Okay, Google Net or Inception Net. This architecture got 6.7% of error rate. Okay, then in 2016 there was an architecture called ResNet. Okay, ResNet got 3.5% of error rate. So that's how, guys, they propose different architecture, different model. Okay, and they got very good accuracy at the end. Okay, and these are the like very famous architecture we usually use nowadays inside pre-trained model. Now if you want to see that, just go to Keras application. So inside Keras application, guys, you can see all the available pre-trained model you are having, like Inception, VGZ, ResNet 101, ResNet v2. Okay, then you are having Inception, ResNet. Okay, then you are having MobileNet, EfficientNet, and so on. These are my pre-trained model. Got it? So see how this model came, because they changed the architecture, they tweaked the architecture, they added some more layer, they use different filters, they use different let's say pooling layer. So that's how they created different architecture. Okay, and they named this architecture, and they also trained with the help of ImageNet dataset. Okay, and they're able to achieve some good results. And this model is already trained with the ImageNet data, because this model is already know like lots of category, like 1000 category this model is already know. That's why we call it as a pre-trained model. Okay, pre-trained model, you can see. So you can see the Keras application now. So this is the size of the model. Why size? Because this model is already trained, the parameter is already trained. Because of the parameter, na, because of the weight. So this is the size of the model. This is the top accuracy of the model. This is the top 5 accuracy of the model. This is the parameter size, like how many parameter it is having. So Inception is having 22.9 million parameter. Okay, ResNet is having 5.6 million parameter. And this is the depth, like how many layer it is having. This is the time per inference. That means CPU, on CPU, how much time it will take to run on a single image. Then this is the time per inference on GPU, how much time it will take to run on per a single image. Okay, so that's how all the metadata they have also given in the website. You can check. Let's say whenever you are creating any kinds of project, whenever let's say you need any kinds of model, try to come here, try to see which model actually you need. So let's say you need a very good performance model which will work let's say in a very less time. Let's say you are more worried about the speed of the model. That time you can go with any smaller model, a smaller size of the model, because you can see smaller size of the model, the millisecond actually it is taking very less and it is super fast. Okay, and whenever you are more worrying about the accuracy, you are not worrying about the speed, that time go with any bigger model. Okay, so that's how guys you can select your model. Okay, it's not like that I can say this model is good. At the end all the model is good. You have to see that okay which model will work better on your task. You have to do multiple experiment, then you will be able to tell that. But I can say ResNet, VG16, Inception, these are the model will be working with most of the your use case. Yeah, all of the written notes are available. You can see in my description there is a GitHub link. Just try to open it up. So there, date wise I have mentioned everything. Okay, Nakul. Yeah. Hmm. Now let me show you guys how we can use these are the pre-trained model. Okay, for our task. So what I will do, I'll just open a collab file. So see this collab file I have prepared, guys. So see, it's not like that always you have to train the model. Okay, it's not like that always you have to fine tune the model. Sometimes let's say you want to do a task and this task is already available inside the model, because I told you now this model is trained with massive amount of data. That means 1 million image and 1000 category. So sometimes the task you are looking for, let's say you want to do what? Let's say you want to do card classification, or let's say you want to do cat dog classification. That time you don't need to fine tune the model, because the pre-trained model you have now, inside that model it is already trained. Only just try to import the model and try to do the inference with that particular model. Let me show you the example. Let's say this is the notebook I have prepared. So here I'm using ResNet 50 model, guys. Okay, ResNet 50. So ResNet 50 it is available here. You can see ResNet 50, and if you click here, so this is the code. Okay, that's how you can use this ResNet 50. So I have imported ResNet 50, then image, just to load the image, and some pre-processing function like pre-processing input and decode prediction and the numpy. So let me import all of the library. And see here I'm not utilizing any kinds of GPU, guys, because this is only for the prediction. I'm not training any kinds of model here. And if you're doing the prediction, that time GPU is not required. You can do it on your CPU machine. See here, if I show you my run type, so this is CPU I have selected. And here what I'm going to do, guys, I'm going to upload some image. So let me upload some image. See in this directory, I'm having some image. Let's say I have car, cat, then dogs, and I can also upload this apple. Yeah, library is important. Now I have to download the ResNet 50 model, and here you have to specify you want to download the pre-trained model. And how to specify? Weight is equal to ImageNet you have to give. Okay, because this model is trained on ImageNet dataset, and you want to download the pre-trained model, pre-trained architecture. Okay, the architecture they trained and they let's say proposed in the Keras application. That means it is available in the Keras app. They uploaded in the Keras app. Now you can download it from here and you can use it for your task. Okay, now let me download the model. Now see this model is getting downloaded. So once it is downloaded, now see the model file format is H5, because I told you if you're using TensorFlow, so the model file should be .h5 format. Okay, now let's say I'll load an image. So let's say I will load this golden retriever. So this dog image. Okay, so here I'll give the path. So here what I'm doing is we're loading the image with the help of image.load function, giving the image path, and this is the target size. Why 224 because if you see the ResNet 50 na, so this image also takes, this model also takes 224 this is the input size. Okay, now here we are converting the image to numpy array, then we are expanding the dimension because you have to provide the batch dimension. I told you before, whenever I showed you the custom training, that time also I showed you, okay, what is this batch dimension. Then we are pre-processing the image. So there is a pre-processing function inside Keras. You have to do the pre-processing. That means all the scaling operation it will perform. Then once my data is ready, that means image is ready, now I'll pass to the model. So here I'm using model.predict. See, I'm not training the model. I'm directly using the model.predict, and the prediction I'm getting, I'm just decoding it because this is the ImageNet category now. And if you want to get the ImageNet category based on the prediction, you have to use the decode prediction, because if I show you only prediction, if I show you the only prediction, so this will give you the number, these kinds of number. Okay, see, so many category it is coming, but you don't know the actual number meaning, the actual category of the number. And if you want to get the actual category, you have to use the decode prediction. So decode prediction, what it does, based on the number, based on the probability score, it will give you the actual level of that. Now see, if I pass it to the decode prediction, now see, it is coming golden retriever with this kinds of probability. Then bloodhound. Okay, see, bloodhound is also a dog category. See, okay, dog category, and the probability 28%. Okay, and golden retriever, it is probability 41%. Now if you see my original image, so this is a golden retriever category. So that's why I told you guys that time this researcher, okay, this researcher also labeled the image in a different category. Let's say you are having 10 different dog. He first of all label this is the dog image. Then in the dog image, he also did the subcategory. Okay, sub labeling. That means whether it's a golden retriever, whether it's a bloodhound, okay, whether it's a red bone. So these kinds of labeling he has also done. That's why you are able to see these kinds of output. Now see, there is another category it has proposed called red bone. Red bone. Okay, red bone. Red bone is also a dog category. Red bone dog I can write. Yeah, this is the dog. What is top 3? See, top 3 is nothing but it is giving you top 3, like top 3 category with a top 3 probability. Got it? No coder. That means here you are getting 3 categories, na? Golden retriever, bloodhound, and red bone. 3 output you are getting out of all the category you have in the ImageNet, and this is the probability of that. This is the probability of that. Got it? So you have to consider the best probability. That means this one, whichever category will have the like highest probability, that time you can consider this is the actual category. That means in my case, if you see that this is the golden retriever, and the golden retriever is getting the highest probability. So my output should be it's a golden retriever dog. Got it? Now let me send another image. So let's say I will send this cat image. Copy path. So this is the cat. Now let's send it here. It will pre-process and I will pass to my model. And see, this is the prediction. So it is predicting the more probability, 81% probability, it is tabby cat. Now let me search for tabby cat, guys, in the internet. Tabby cat. See, this is the tabby cat. Okay, and if you see the image, it is also tabby cat. This is also tabby cat. Okay, then the next one, it is predicting tiger cat. Okay, then Egyptian cat. Now let me give another sample. Let's say I'll give this car image. So this is the image car. Oh, sorry, car, this one. Now if I pass to my model, so it is predicting this is a minivan. Okay, so if I search for minivan, See, minivan. I think this minivan. Okay. Then the next thing, it is predicting sports car, then car wheel. Got it, guys? So this is called actually pre-trained model. That means with that trained model, you can also do the classification without the training the model. So first of all, the problem is that you are solving. First of all, try to check whether this problem is available in the model or not. Let's say you want to do car classification. So car is already available in the model. Okay, car data is already available. They train. You don't need to train the model. But let's say if you have some specific categorical car, specific category or specific level car, that time you can do the fine tuning. You can use transfer learning that time. I'll tell you the transfer learning technique, how we can fine tune these are the model on top of our custom data. Got it? So till here, guys, are you clear? If you clear, just please write clear in the chat. Tell me, have you understood this pre-trained model or not? What is this pre-trained model and why it is required, and why people are using pre-trained model instead of using the custom architecture? And here you don't need lots of data. Okay, if you are using pre-trained model or transfer learning, you don't need lots of data for training. If you have less amount of data also, you can still train the model and get the good accuracy, because this model is already trained with benchmark data, which is nothing but ImageNet. So let's say, see, just try to consider, if you have studied machine learning, if you already know machine learning, so teaching deep learning would be easy for or not? Tell me. So whenever I will teach you deep learning, so should I again start from machine learning, or I can start from deep learning? Tell me. Definitely I can start from deep learning. So similar concept. So you already trained with some amount of data. So you already know the machine learning, right? So learning deep learning would be easy for you because you have the idea about artificial intelligence and machine learning. So as a mentor, I don't need to train you from scratch. Okay, I don't need to, let's say, teach you from scratch. I'll directly start from deep learning. So this is called actually transfer learning concept. Okay, transfer learning. That means you know something and I'm transferring to you some new information, and based on that you are upgrading your, let's say, knowledge. Got it? That means you are working like a pre-trained model. You already trained with some data. But if you're completely new, to artificial intelligence, machine learning, that time I have to train you from scratch. That time you can consider you as a custom model. Clear? Fine. Now let's try to see, guys, the transfer learning approach. Okay. See, in transfer learning, what do we do? Let's say here we use some pre-trained model. Let's say I'll take one pre-trained model architecture called VG16. Let's say I'll take this architecture just to explain the concept. Okay. So let's say this is my VG16 architecture, guys. Okay. Let me copy and I will paste it in my board. So here you are having some layer. That means you are having convolutional layer. You are having pooling layer, convolution layer, pooling layer, convolution layer, pooling, convolution layer, convolution layer, convolution layer, then pooling layer. That means 3 convolutional layer, then pooling layer. Then again 3 convolution layer, then pooling layer. Then again 3 convolution layer and pooling layer. And here you are using dense layer. Here you are using dense layer. That means till here this is called CNN. And here this is called ANN, artificial neural network. Okay. And I think you know, guys, how to understand any kinds of architecture, right? Yes or no? I already taught you these basics. What is convolution layer? What is pooling layer? What is the, let's say, filter size? What is the stride size? Everything I already explained, right? Yeah. So if you count all the layer, 1, 2, 3, 4, 5, 6 like that, you will see it will have 16 layer. That's why we call it as a VG16. Okay, VG16 layer. And it is a pre-trained model. This model is already trained with ImageNet data. Okay, ImageNet data. And this is the top accuracy of VG16. You can see in the Keras application. So if I go back, VGG16, so top accuracy 71.3%. This is the size of the model, and this is the depth of the model, 16 layer, and this is the speed of the model on the GPU, on the CPU. Got it? Now in transfer learning, what we do? See, in transfer learning, what we do? Let me rub. See, In transfer learning, first of all, we'll try to download a pre-trained model. Let's say in case I'm considering VG16, I have downloaded it from the Keras hub. Now, what I want to do, let's say you are having a specific task. Let's say out of 1000, okay, 1000 category from the ImageNet. Okay, let's say you have some other unique data. You have some other unique data. So let's say as of now, I can consider you are having this data called bones break, or let's say bones fracture data. So let's say this data I have downloaded from internet. So this is a bones fracture data. So you're having two kinds of fracture, spiral fracture and oblique fracture. So see, this is the spiral fracture. Okay, this is the bone CT scan, guys. You can see bone CT scan. So you can see all the images one by one. Okay, so here is a fracture. So again, if I show you, this is the fracture. Okay, so this is called spiral. Okay, spiral fracture. And here you can see spiral fracture. Spiral fracture. And you are having another category called oblique fracture. See, this is called oblique fracture. Okay. Now, can everybody tell me these kinds of data is available inside ImageNet? Yes or no? This kinds of data is available in ImageNet. So you can search like ImageNet 1000 classes list. So I think somewhere they have given 1000 classes list. Let me show you. So see, these are the classes. You can read. Okay, you can read anywhere. Okay, if you found this bone fracture category, you can let me know. I think it is not there. Okay, as per my understanding, it is not there. Bone fracture, it is not there. You can even search here. Bone fracture. Red bone is a like I think it's a dog. I don't know what is this. Red bone dog, I think. Yeah, it's a dog. Okay, but bone fracture data is not available here. Okay, it's not available here. Now that time, if I use my pre-trained model and if I do the inference operation, that means like that. So will my model will give you the output? Yes or no? Tell me. Will my model give you the output? If any label is not present, if any image is not present in the ImageNet data, that means in the pre-trained model, so definitely that time it will not give you the output. That time what you have to do? That time you have to use the transfer learning technique to fine tune that model. Okay, on your custom data. So this part we'll try to learn right now. Okay, so we'll use this bones fracture data. Okay, and we'll try to use a pre-trained model from the Keras hub, and we'll try to fine tune on top of that. Okay, and most of the tasks you will be solving in that way. You are not going to train from the model from scratch. Instead of that, try to take the model from the Keras hub. Any kinds of pre-trained model you can use, and use your custom data to perform the entire training and try to use that model. This is called transfer learning. That means this model is already trained with some data and you are transferring some more information to the model. The explanation I showed you now. So let's say you already know machine learning, and if I want to teach you deep learning, I don't need to start from machine learning. I can start from deep learning itself. Okay, same concept. That means model knows already all the information, like a good amount of information. Now I'm giving some more data. I'm giving some new data to learn. Okay, I'm transferring some knowledge. This is called transfer learning. So many people like have the confusion between transfer learning and pre-trained model. Now I think this is clear. What is pre-trained model and what is transfer learning? Both are not same. Okay, there is a difference, but at the end, to perform the transfer learning, you need a pre-trained model. Okay, there is a relationship. I hope it is clear. So how was the session, guys? Are you liking it? Tell me. Are you enjoying? Or it is boring? Let me know. Are you enjoying the session? Are you able to learn something, guys? Yeah, thank you. तो फिर एक लाइक तो बनता है गाइस. Just give me a like. Hmm. Thank you guys. Okay, now let me show you guys how we can use the transfer learning technique to train any kinds of pre-trained models on our custom data. So for this, I again prepared another notebook. So this is the notebook, guys. See, I think you will find this notebook similar notebook, the notebook I shared you previously for the custom image classification. So I just modified this notebook, guys, with my pre-trained model. Okay. So see, first of all, let's connect the notebook and make sure you select the GPU as a runtime, because now we are going to do the training operation. So see, here I have selected the GPU. Sir, in real time, we cannot say how many convolution NN max pooling layer are required for our custom dataset. This is also reason for going to transfer learning. Yeah, Balaji, you are right. And one thing, guys, see, in transfer learning, you are not going to take the entire model, okay? Because if you see here, you are having two kinds of architecture. One is the CNN architecture, that means this part is called CNN architecture, okay? And this part is called ANN architecture. And this is the pre-trained model. That means in the last layer, guys, it has 1000 classes, okay? 1000 classes. But the model now I'm going to train. The model now I'm going to train. So how many classes it is having? Tell me. So the data I'm using currently, this bone fracture image, okay? So how many category I have here? Only two category, right? Spiral fracture and oblique fracture. That means only two category I am having. That means you have to remove this part, guys, okay? You have to remove this ANN part. Whenever you are downloading the model, that time you will tell, I don't need the FC layer, I don't need the FC layer, I'll create my own custom FC layer, okay? Just try to remove the FC layer, only I need the convolutional layer, okay? Because the convolutional layer is required. Okay, the convolution layer is required to extract the relevant feature from my image. I don't need the dense layer, I don't need the FC layer. The FC layer I will add my custom layer based on my category, how many category I have inside my data. We're fine tuning, see, we're fine tuning. Fine tuning and transfer learning at same, okay? We're transferring some learning, okay? This is called fine tuning, not that. Hmm. Hmm. So that means always remember, guys, whenever you are doing these kinds of transfer learning or fine tuning, make sure you remove this FC layer, okay? FC layer you don't need. You will be only using the CNN layer, and the FC layer you will try to remove it. And we'll add our own custom FC layer, okay? With the category we are having. Let's say I am having two category here. I'll add only two neurons in my last layer. This is the idea. Fine. So let's connect the notebook. So after that, I will also upload the data. So I already have the data, guys. You can see it is a zip file. I'll also share this data, guys, in my GitHub. So link is mentioned in my description. So after the session, please try to check there. I'll try to upload the data as well. So this is the data, bones data. So let me upload the data in my Google Colab. So guys, see here I'm having very less images, but whenever you are training the actual model, make sure you increase the image size, okay? So I downloaded it from the Kaggle, okay? Then what I did, I deleted some images, guys, from here, because this is a live session, and if I'm using like free collab, and if I'm showing you the training, it will take lots of time, right? So that's why I removed some image, guys. You can see only I'm using so let me show you. So training images, how many training images I have? So 74 training images I have, okay, for both of the category. And testing images I'm only having 12 images, just to show you the quick training process, okay? But whenever you are training the actual training, see this bones dataset is already there in the Kaggle. Let me show you. So this is the data, guys, bones break classification data, and it is having so many classes, okay? It is having so many classes. See, so you are having evolution fracture, comminuted fracture, then fracture dislocation, then green stick fracture, hairline fracture, impacted fracture, then longitudinal fracture. Okay, so here I'm only using oblique fractures, and I'm only using spiral fractures. Okay, if you want, you can also use all the, let's say, category here, and it is having like so many images. Okay, inside that you can see it is having so many images, but I deleted some of the images just to show you the quick training process. That's why. Yeah, in transfer learning we just remove the NN layer. Yeah, you can also remove some CNN layer as well. Okay, but we don't do that usually. But if you want to, let's say, do some other experiment, let's say you want to remove some CNN layer also, you can do it. Feel free to do it. Okay. But there is a possibility if you remove some CNN layer, this model will not work better that time. That's why we are not going to remove any kinds of CNN layer. Okay. Because CNN is for the feature extraction, and NN is for the classification. That means this CNN is only for the feature extraction. It will extract the features and it will give you the feature map, and from the feature map with the help of FC layer you have to do the classification. Okay, so for feature extraction this CNN is fine, I don't need to remove anything. But NN, this particular layer I don't need, because here I'm having 1000 category. Okay. So this dataset link, guys, I will also share. You can even search like bones break classification data in Kaggle. You will also see the data. So what I can do, guys, after the session, you can download the entire data and you can build a model on top of that. Otherwise, there are some more data are available, guys, on not only bones break classification. If you go to the Kaggle website, let me show you kaggle.com. Go to the datasets and search for image classification. Image classification. See, these are the data you are having for the image classification. Okay, see, thousands data are available. Total 5,980 datasets are available for the image classification. You are feel free to choose any dataset, guys. Okay, the way I'm showing you the implementation, you have to follow the same thing. Only the data will change. That's it. Okay, so see, guys, here I'm going to I'm going to teach you how to fish. Okay, I'm not going to give you the fish. So in my every, let's say, class, in my every course, I usually say this line: I'm going to teach you how to fish. I'm not going to give you the fish. Okay. If I'm giving you the fish, okay, you won't be learning how to catch the fish. Fine. So as a mentor, I can give you the guideline. I can give you the, let's say, conceptual understanding. But as a learner, if you want to be a good developer, definitely you have to explore. You have to practice. Okay. Yeah. And I want you to be, become pro, okay, in this particular domain, at least in computer vision domain. So if you get any kinds of problem statement, any kinds of task, you will be able to solve that without needing any kinds of help. But if you expect from my side, let's say, I will provide each and everything, I will provide, let's say, all the projects, then you won't be able to learn. So I'm showing you one implementation. I'm using one particular data. Now you are feel free to explore thousands of data over the internet. Okay, the logic will remain same. Because these are the domains is updated domain. Okay, every day there are new research are coming, and it's not possible for me to also show you all the, let's say, updated models. As a learner, you have to keep yourself updated always. So if I'm teaching you one topic, so definitely there is a relationship, this topic with the updated topic. So learning new topic would be easy for you. And this is the foundation I'm building to you right now. Okay, great. So here I'm using free GPU Tesla T4. Now I'll upload my data. Let's upload the data. So bones data, I'll try to upload it. And let's unzip the data, because this is a zip file and this is the command. You can copy the path and mention it here and unzip. After that, you have to mention the image size. So 224 224, because if I show you the VG16 model, guys, I will be using VG16. So this model also takes 224, 224, comma 3. Okay, this is the image dimension. That's why we are giving this image size here. Okay, so whenever you are using any model, try to go through, go to the documentation and see, okay, what is the image input, what is the size of the image. And 3, there is a 3 channel, we are also adding the 3 channel here. Okay, now here we are defining the training path. So if I go to my bones data, so this is the training path and this is the validation, that means testing path. I'm using testing data as my validation data. Now here we are importing some necessary library, and you can see I'm importing VG16 model. You can now import ResNet 50, you can import this Inception, okay, anything you can import, guys. You can use exception, you can use 19, you can use ResNet 50, anything you can import, okay. And how to import? So they have already given the code in their documentation. Okay, let's import the library. Then after that, we have to download the VG16 model, and here you have to specify the input size. So here we have given the input size, guys. You can see input size, and we are adding 3 here because 3 is nothing but it's a channel. Okay, so we are adding the 3 here, and we are mentioning the weights is equal to ImageNet because I want to get the ImageNet data, ImageNet model, that means a pretrained model. And include top is equal to false means here I'm removing this dense layer. Okay, I don't need the dense layer, I only need the CNN layer. That's why you have to give the parameter. And if you include is equal to true, okay, that time it will also include this layer. Okay, but we don't need that, that's why I'm removing it. Now by default, okay, by default the trainable, okay, layer v16 layer trainable is equal to, it would be true. So let me show you all the layer, the trainable parameter would be true. So print layer dot trainable, it would be true. So you have to make it as false. See, all the parameter, also all the layer, it is true. That means true means whenever you will do the fine tuning, it will also update the weight in the CNN layer. But I don't want that. Okay, I don't want that. I want to freeze. I want to freeze the CNN layer I am having. Okay, because I want this particular layer to be extracted my features. That is the like use of the pretrained model. Now, if I'm changing the weight in this architecture also, that means we are, training customly, right? We are, let's say, changing the updated weight, but we don't want that. We have to freeze that weight. Okay, we have to freeze the weight, and we'll be only training in the FC layer. The FC layer I'm going to add, custom FC layer I'm going to add. I'll only train inside that particular layer, and the layer I'm having CNN, it will utilize for the feature extraction. So when we freeze some layers and train, the model accuracy is increased. See here we are doing it. Okay, now see, you have to make it as freeze. So how to freeze? Layer dot trainable is equal to false, you have to give. Now if you execute this code again, now see, it would be false again. That means now this particular layer would be this particular layer won't be training. Okay. So these are the small concept, guys, you have to remember, because I have seen many people they do the mistake. They, instead of like doing the freeze operation, they start the training. Okay, you don't need to do like that. And now if you see, all the trainable parameter are false, okay, in the convolutional layer. Now this is the entire architecture of VG16. Now you can pause the video and you can see how this number came, okay, because I showed you how to calculate the number as well. You can see the architecture as well, VGG16 architecture, VGG16 architecture. So you can see like how many kernel, how many, let's say, what is the kernel size, each and everything they have mentioned here. Okay, you can see. Now, if you want to get like how many category you have inside the folder, you can use glove library. I think I already told you previously. So it is having 2 folder, spiral fracture and oblique fracture. That means number of classes I'm having 2. Now here I'm adding the sequential layer. I'm adding my VG16 model, that means the pretrained model. And here I'm adding my custom dense architecture, custom dense layer. That means this layer I'm adding right now. My custom, not the pretrained one, I'm adding my custom one. So before that you have to do the flatten operation, then the dense layer. And you can see dense layer I'm using 256 neurons, and activation I'm using ReLU. And at the last layer I'm using my number of classes, that means two neurons only. Okay, here you can see, I think number of classes 2, that means 2 neurons I'm using at my last layer. And activation function I'm using softmax. Either you can use sigmoid, okay, it's up to you. Softmax will give you 2 probability score, and sigmoid will give you the 1 probability score. You have to make the threshold. Now this is my summary of the model. That means here this is the trainable parameter right now, guys. Okay, so these are the parameter you have to train. Now let's compile the model. And here I'm using categorical cross entropy, optimizer Adam, matrix accuracy. Now we have to do the data augmentation, guys. Remember, I taught you the data augmentation and how it can be done with the help of image generator. So this is the augmented object we are creating. We are rescaling, we are shading the image, we are doing the zoom raise, we are doing the horizontal flip. Now we are loading the image. So found that many images belonging to class, and this is the testing image. Now we will start the training, guys. Okay, you can see I'm passing my training set, validation set, number of epoch I'm training 10 epoch, and step per epoch and validation step per epoch. This would be length of training set and length of testing set. Now your training will start. And one thing, guys, I want to let you know. So here I'm having very less images. Okay, only 76 images. This is enough, not enough for the training. So it might be overfitting condition. Okay. So what you have to do, you have to use more images for the training. But just to show you the quick training, I'm using very less images, guys. Okay. So that means the prediction I'm going to do. There might be some issue. There might be mistake because of the data. So whenever you are training your own model, guys, make sure you are using lots of images. Okay, lots of images in the training folder. But if you see my data, very less. Bones data, training. See, I'm only having 74 items. This is not enough. Now see, training is going on, and you can see the real-time accuracy, losses, validation accuracy, and losses. So training is done, and you can see the accuracy 88 and validation accuracy 53. That means again it got overfitting condition because of the data. Okay, so you have to increase the data, guys. Okay, I'm telling you, guys, you have to increase the data. If you increase the data, definitely you will be getting good accuracy. And now if I show you the results in the graph, so this is the graph. You can see there is a overfitting condition. This is the loss and this is the accuracy. There is a overfitting condition. Okay. Now this is the evaluation on top of the test. So this is your loss and this is your accuracy you got. Now if you want to save the model, guys, this is the code model.save. It will save the model as a H5 format. Even you can also load the model using load model function. Now if I want to do the single image prediction, first of all I will import the image. Now here you can pass any kinds of image. Let's say in the bones data training, I'm going to take the spiral fracture image. So let's say I'll copy a image path and here I can mention it. So this image, first of all, you have to load. Okay, I'll load, and this is the target size and this is the image. That's how your image looks like. Now I have to convert it to the NumPy array. Okay, and here, guys, what is the category? See, as per the alphabetical order, okay, that means oblique fracture would be 0 and spiral fracture would be 1, guys. Okay, that means oblique it is coming at the first, then spiral image coming at the last. Okay, that's why this particular category will assign as 0 and this particular category will assign as 1. That means if your model is predicting 0, that means it's a oblique fracture. If your model is predicting 1, that means it's a spiral fracture. Okay, so this is my matrix. Now this is the visualization of the image. So this is the spiral fracture. Now I'll show you the shape. So this is the shape. Now I'll do the scaling operation. After that, here we are doing some pre-processing. That means we'll be expanding the dimension and we'll do the pre-processing of the input. Now here we are passing it to my model.predict. So this is my output, guys. This is my output. Okay, now the more probability, guys, you can see this one. That means if you count the index 0 and 1, that means the prediction would be 1. See, prediction would be 1, and if it is 1, that means it's a spiral fracture image. Okay, so that's how, guys, you can do the single image prediction. Now, guys, this thing I have done in my Jupyter notebook, right, in my Colab notebook. Now in the next class, I'm going to show you how we can convert the entire project in the web app. We'll try to create the web app. That means their user will upload the image and they will do the prediction there. Okay, because I feel like only doing the code on the Jupyter notebook, it's not the, it's not enough. So that's why we also need to learn how we can create the web application as well. After training the model, okay, how we can use our trained model to create our web application. So next class, guys, I'll try to teach you that part. All right. So yes, guys, this was the transfer learning, and that's how we can do the fine tuning with our custom data. Now tell me, guys, how was the session? How was the session, guys? Did you get it? The entire concept of transfer learning and pre-trained model. Let me know, guys. Any question? Any question? Let me know, please. Let me know. Any question, guys? Or it was clear? Yeah, I hope, guys, everything is clear. And yeah, no question. So, guys, next class I'll show you how we can create the web app. Maybe I'll be using Flask to create the web app. So there we'll try to create a beautiful web applications. Their user will upload the image and they will be able to get the prediction. Okay, so this is the topic of the next class. Then now we'll try to move to the next task, which is nothing but object detection. Okay, we'll try to move to the object detection. What is TensorFlow? TensorFlow, it is the framework for the deep learning. Okay. And one class I'll be taking for the PyTorch. Okay, so with the PyTorch, how we can also work on the image classification task, or let's say in CNN. Okay, yeah. So fine, guys, we are done with the class. So this was the agenda for today. I hope you liked it. So if you have liked it, guys, so please try to hit the like and subscribe to my channel. So let's hit 50k subscriber, guys. This is my request to you. So please try to support me, because your support is the biggest motivation to me. And continuously I'm uploading like different content. If I've seen, like, I've uploaded end-to-end projects, I've uploaded like Amazon SageMaker tutorial. Okay, I've uploaded the LangChain. Soon I'll be also coming up with a like generative AI course, like updated generative AI course. Like there will be learning the application development, we'll be learning the AI agents development, we'll be learning the MCP. Okay, so soon I'll try to publish that course on my Udemy. Okay, so guys, let me show you guys. This is my Udemy. So this is my Udemy profile. So guys, you can see this is my Udemy profile. Okay, so here one course is already available. So MLOps real world machine learning project for professionals. So this course is already available there. And soon I'm going to publish that generative AI with AI agents and MCP for developers. Okay, this course. And there we'll be learning the professional level development. Like we'll be exploring the LLM ops. We'll try to explore the AI agents. We'll try to explore the MCP. Okay, each and everything we'll try to cover there. Yeah, and I have already received some great feedback, guys. Some great feedbacks and ratings. So if you're interested, guys, you can also check this course. Okay, it is available. Yeah, YOLO model will try to cover as well. Okay, everything. So if you want to search my Udemy profile, guys, just search for Udemy, or you can search for like my channel, like, okay, DS with Bappy, DS with Bappy Udemy. Okay, so the first link you can see, DS with Bappy Udemy profile. So you can see that this is my Udemy profile. So I created it recently, guys. Okay, recently I created it. The same name, my YouTube channel name, DS with Bappy Udemy. If you search on Google, you will get my profile. Make sure, guys, this name, DS with Bappy, DS with Bappy. Okay, not any other name. Hmm. Okay, so guys, we are done with the class, and I mean, I will share all of the resources in my GitHub. Okay, after the class, you can check it out, and let's connect in the next class, guys, with a new topics.